my screen and we can start. So I'm talking about data lakehouses today and how to make that in Azure. And because of some strange things happening this summer, so I came back from summer holiday finding my Azure account with a $3,000 bill on it. I have deleted almost everything I had and gone begging to Microsoft, and luckily they were kind enough to reinstate the account without any bills. But it means that I have to show everything about data lakehouse architecture for you today in Synapse and not in both Databricks and Synapse, because data lakehouse is fun that way in that you can make it in different technologies. But let's go on. First of all, I just wanted to take you to a brief history of why we are talking about data lakehouse architecture and where we are, because there is a history behind this, and we all know about the data warehouse. Most of us, I think, have spent a lot of time doing things in the data warehouses. It's been around for a while, even longer than I have been working, even if it's hard to believe with the color of my hair. But it has evolved over time. It contains a lot of structured schema on write data. So it means that you have to shape everything relational data, yeah? And it stores historical data from various sources that needs to be transformed and aligned as it is loaded into the warehouse. And typically you transform before you store it, but of course it depends which marketing department you're listening to, if you do ELT or ETL or some kind of a mix in between. But the data warehouse itself is great for business decisions. How is our business doing? What have we solved the last year? And how can we compare that to how we did 10 years ago? And it does that by aligning data from various sources and enabling us to do cross-system querying. That means we need to make sure that we have high data quality and the focus on the numbers being exact, which means that we get long development life cycles. I mean, this has evolved over time. So agile methodologies, data ops / DevOps / XOps methodologies have reduced that development life cycle. But still, the rumor about data warehousing is that it takes so long, it's so expensive that people will get, or customers will get, the data they asked for after they've forgotten what they asked for. Then, with the advent of big data, 2008, 9, something like that, we got the problem of data coming in faster in various sizes and shapes, and the amount of data that we got in started to put strains on the relational database systems, which meant that we struggled to get a good performance of data warehousing. So with big data solutions such as Apache Hadoop, there came another solution, which was the data lake. And the data lake itself gained foothold around 2011. And it again tries to answer to the pains in the data warehousing of the V's of big data. And of course, I use 3. Marketing departments might want to use 4 or 5 or 7 or 10. But volume, variety, and velocity of the data that is coming in. And the data lake itself have 2 typical variants. I mean, in data warehousing, you might remember that we have 3 typical variants. We have Kimball, Inman, and Data Vault. In the data lake, you could see it's 2 versions. One was the raw data lake, which is just dump everything in, and that users dig into that and find and create reports on top of it. And then you have the business data lake, or the layered data lake. And the layered data lake, again, gives you various layers that have various transformation stages, which means that various users could access various layers and get the data they needed there without having to do a lot more work. So the principle of the business data lake might sound a bit familiar in some sort of, for at least people who have worked a bit with data warehousing, in that you land all the information that you can as is with no modification. And then you encourage line of business to create point solutions. And again, that means that the line of business are the ones that are developing the reports or the data marts or what have you. And then let the line of business decide the cost performance of their problem, which means that IT can concentrate governance on the critical points only, making sure there is an uptime, making sure that data is flowing into the lake in a good manner, and so on. And in this aspect, the corporate view, so data warehousing kind of view, is just another line of business view. Again, IT is no bottleneck. It's the line of business that needs to think about how to handle that data and deliver it onwards. And all kinds of information is necessary here. You can have unstructured, or you can have semi-structured or fully structured data in a data lake. And of course, never assume the lake contains everything, but scale is driven by demand. You should be able to use compute systems that can scale up or out as well as down and in. And then this, the data lake transforms data on from the raw layer upwards into the curated layers. And again, if you're using data warehousing, you typically have a operational data store, or you have a staging area, and then you have data warehousing layer, and then you have your data mart layer, and perhaps even the reporting views layer on top. Kind of familiar in this aspect. But the various use cases and the users get access to various layers of the data lake means that you can have data scientists and data engineers going into the raw layer, whereas analysts might go into a semi-curated layer and the users go into a fully aggregated layer. But this means that data lakes are great for trends and ad hoc analysis. You don't have any focus on exact numbers, which means that you don't really know what kind of data quality you have, which means, again, it's great for trends, but you can't really make sure that you have a full control of what happened or how did we perform this year versus last year. But it also means that there's very short time to market development life cycles, which is good for business. And again, seems that the data warehousing solution is a bit old-fashioned, or it seemed that way back in 2011. And the data lake is a great enabler for data science and self-service, because especially for data science, you don't want to model out, as you do in a data warehouse, you model things into being able to do cross-querying and the process of querying and so forth. You don't want that for data scientists. They want the raw data and the noise that we model out of when we're loading data up in the system. Of course, there is a great danger of a data swamp, in that you never know, since you're pushing as much data you can in, don't really think about the use cases for it. If people then don't know what data is there, and it's hard to find out what is where, you end up with a lot of data that is taking up storage space and gets expensive over time. And on top of this, the traditional on-premise Apache Hadoop systems struggled a lot of scaling, because it was hard to put in another storage node or compute node into the system without having to rebuild the whole thing. These things have, of course, improved over time, but it's the cloud's data lakes really helped in that aspect. But data lakes lack ACID support, so atomic, consistent, isolated, durable. You don't have control if you need to update a row or delete the row or change things. You need to take that file where this data is stored, then you need to do the changes you want in memory and then create a new file afterwards. So it is not a fully ACID system, which a traditional relational database is. And query response is an issue for consumers, because a data lake is just a storage account. So you need to have compute nodes somewhere, and that could normally end up you being on the consumer side. And it's not stored in a way that is fast for makes a quick response time. There have been changes there as well for things like you introduced Parquet files that were optimized for Spark engines. You have the ORC format, you have Avro formats, all trying to do binary formats that are optimized for some query engine or processing engine. But traditionally CSV files, which were the first we got, didn't really respond well. And you can't take on the cross-system querying of a data warehouse without creating data warehousing pipelines. Again, transforming, extract, transform, load principles, and the time that all the data quality checks and all the numbers checking entails. And most systems or companies have a data warehouse already, so why should you throw away that investment? So better to look at some of the functionalities and expand beyond what the data warehouse can mean for your users in other ways. And this is where the data lakehouse came in. And the data lakehouse takes on the data lake, but also the data warehouse, because it tries to deliver both a regular data warehousing system as well as a big data analytics solution in a data lake. That way, it empowers both the self-service BI as well as traditional BI and data science, and also the self-service analytics. But you still need proper services for performant data warehousing solutions on large data sets. So you need to make sure that you have the right kind of compute nodes available for this. And of course, as the data size grows of your data lakehouse, you will still face the same kind of challenges that you do in a data lake. You have a challenge of a data swamp. So you need to have some kind of way to make sure that your users can find that data. And not only to find what data is where, but also some kind of a data quality report. So this data is fully loaded into a data mart, it's curated, it's being checked and verified. This is exact truth. This is the single source of truth of the data warehousing. Whereas this data source is a time series. We haven't done a lot with it, but it's great for trending or ad hoc analysis. So these kind of things need to be put into place in data governance tool of some sort, data catalog, for instance. And the features of a data lakehouse is that it has transaction support, so it's a transactional system. It has schema enforcement and governance, so making sure that as you put data into the data lakehouse, you put it into a schema. And that schema will be enforced as you load data in. You cannot load data in and think about schema later. It has to be enforced. But also it means that you can have governance around that, and you can have evolvement of the schema. So you can change the metadata type of a column, or you can add another column, and it will support that as well. Of course, it needs to have business intelligence support, being a data warehousing solution as well. And importantly enough, that storage is decoupled from compute. And this is important from a cost driving perspective, because you don't want to be using big data solutions with clusters running hot all the time. That's what you have a relational database for. But the data lake or the data storage solution means that you can pay, say, 1/5 of the price of storing a table on a data lake versus the same price for that table in a SQL database. It needs to be open, so it needs to be open source support. So you can take that data. It's not your database vendors schema and your database vendors systems. You can take that data and say, okay, sorry, Microsoft, I'm not interested in working with you anymore. I want to go to Google. And then you can run things in Databricks, or you can run things on other supporting systems. I think BigQuery also supports data lakehouse in some form or fashion. And of course, you need to have support for the diverse data types that you need to have in a relational database system, as well as diverse workloads. And the data lakehouse needs to support end-to-end streaming to enable you to build both Lambda architectures and so on, so you can have both real time as well as batch processing. And at the heart of the data lakehouse is the Delta Lake. And the Delta Lake is an open source format. It was created by Databricks, who then outsourced or open sourced that under the general Linux open source license. And Delta Lake brings ACID principles to the data lake. And it supports both S3, ADLS, so Azure Data Lake Storage, Google Cloud Storage, as well as traditional Hadoop file systems. It has a unified batch and streaming source and sink, so you can use you can stream data into a Delta Lake table and then stream it out again as well using triggers. It supports schema enforcement. It supports schema evolution, again, adding new columns, changing metadata of a column. It has transaction logs, which means that you can see what's happened to a row over time. That also allows you to do time travel, which means that you can take a look, jump back a while, and see how that data, that row has changed over, say, the last week, the last month. The length that you can do time travel on depends on how large transaction log you're allowing to keep. And of course, it supports updates and deletes, audit history, and underneath the hood, the data is stored in Parquet files. So each partition of the Delta Lake table will be a Parquet file, and then there's an API wrapper around that that exposes that data as a single unified table. And the Delta Lake formats and the data lakehouse format is the architecture, sorry, will look something like this. So you have data coming in, it will be landed into bronze layer, and the bronze layer is your raw data lake. Then you have silver tables or refined tables. Typically, that's where you have your, for instance, your data warehousing or your EDW tables. You align some system keys, you align date for time format and so on. And then you have your gold layer, which is your feature store or your aggregated data store or your data marts if you want. And you should see, if you look back at what I told you about the business data lake or about what we know about the data warehousing solution, this is basically the same thing. So in bronze layer is your staging or your operational data store or your raw lake. Silver layer is your data warehousing or your curated tables in the data lake. And then you have your gold layer, which is your data marts and feature stores in your data lake. And again, it supports all traditional formats, so you can take that data and move it wherever you want. And Synapse supports Delta Lake formats in various services. Amazon Redshift supports Delta Lake as well. BigQuery, as I mentioned, should also support it, which means that you can read and write and take that data with you if you want to change provider. It's open source. If I just skip to a demo, so you can see, I've taken the very popular open data from New York cabs. I have loaded all the yellow cab data into the files here. And right now, these files are about 655 megabytes each. This is for 1 month. Okay, I have started my pools. Let's see if they should be started as well. If we go now into So what I want to do first is I take that in using Python. I load that file into a data frame. And that took about 51 seconds when I imported the January file. I'll just do it again for you now so we can have another file in. This is the February file. And of course, there's a failure. Yep. Let's see if I can get that one run. Hopefully this one. This one is also run before. So here I define my Delta Lake table. As you can see, this is Spark SQL. It's pretty close to ANSI SQL, so it's as long as you start or you know T-SQL, it's quite easy to understand and get the grip on Spark SQL as well. Slightly different naming conventions on some of the data type, but yeah, mostly familiar. So I've defined my table, and I told Spark that I'm using Delta, which is the important part here, and then where I've stored that file. So if you go to my storage account again, it should be in Close Analytics, and we have, let's see what we call it, Delta Demo, yellow trip data. And as you can see here, these are all the Parquet files that are they don't look, it's not meant to be human readable by us. We don't really care about what those files look like, but that's the way they look. And then you have the transaction log systems or files underneath, which are JSON files. And if you can see, if you can edit, you can see, take a look at it. Yeah, so it's quite simple, just tells me the metadata, when it was committed into being, and so forth. So it's pretty straightforward. But the interesting thing then is if I want to insert data into it, let's see if I can try once more to get, I'll try one of the older nodes and see if I can get it running. Just so I could show you how to insert data. But it wants me to wait minutes. That's not going to be nice for a demo. But again, it's pretty straightforward SQL. Insert data into the yellow trip data table that I have defined. Using default is the schema that always comes up if I don't enforce a schema on it. And then from the data frame that I had loaded data into. And then afterwards, afterwards we can go and do a select on that data and see if I can get, oh yes, it's running now. Why? Let's just, that's fun. This is always why it's fun to create or run demos. Even though they worked perfectly fine just before, there's some issues now. Go back and find out what's that state of, if there's a namifying. Oh, I didn't have March, February, that's why. Let's see. But it should take only a couple of seconds before it's done. Yeah, so 14 seconds. And we can try again. I import SQL. This one should fail because it's already existing. Yeah, no data. It's there. We'll insert some rows. There we go, and we'll do just a quick select to see if we can get some data out. And as you can see, it's straightforward SQL, and there we go, it's run, I got data out, so that's perfect. I can also update. So now I want to update and set wherever I have the vendor ID 2, I want to, and the vendor to the PU location or pickup location ID is 1. Then I want to change, set vendor ID 2 where the, I change the vendor ID 2 to wherever we have this pickup location and this drop-off time. So let's see. And why did not that? So it took 9 seconds to select. It took 36 seconds to insert that amount of data. And it took 17 seconds to do an update. It doesn't, I forgot to put in a location to have an output of how many rows it changed, but there were some. And then I can do describe history, so I can take a look at the transaction log and see what happened to the rows lately. And okay. Yeah, so you can see here that it has had some changes happening, removed files, and so forth. So you can take a look into the transaction history, and then afterwards you can do load the previous version of the tables of the delta table into a data frame to see how it's to look at changes and compare for previous. And in this aspect, I didn't put into the versions as of, if we take one and see if there's anything. And the thing is, I go for the format delta, and I want to look for the versions as of, so version 1, 2, 3, and so forth, and the table I'm looking for, and then put that into a data frame. See if we can get something from version 1. Yeah, there we go. So it's, I mean, it doesn't look pretty in the Synapse GUI like this, but it can be exported into it. You can read or connect to this using SQL scripts as well if you want. And you can, of course, connect directly to Delta Lake formats using Power BI with a connector, or you can go through SQL endpoints. So it's quite nice and easy SQL format, but it is a file or a set of files. It's quite handy. So the thing that you then need to think about into any kind of data warehousing system is, of course, you want to do some ETL jobs, and you want to load that data somewhere. And a traditional data lake, you load that into a Parquet file, and then have to do changes and so on that. This gets a lot simpler using the data lakehouse because everything is tables, so it's easier to manage any updates or retrievals or deletes. And again, it's it looks and feels like a SQL table for any of us who are just querying it. If you're looking into the object store, of course, it's as you saw, it looked quite different, but that's something that most users will never bother to look at. We need to serve that data as well, of course. And the data lakehouse, yeah, if you wanted waffles and coffee. The benefits of the data lakehouse is, of course, that you are using compressed files in a data lake. Parquet files are binary, columnar files that compress data quite efficiently. It's the same as if you're using a column store index, for instance, in SQL, it will compress down to a 10th if you're lucky or the data is good enough. And of course, because you're lying around data just in a data store or object store, it is a lot cheaper. I mentioned 1/5 of the price versus a database, and that's not far off. Compute is needed to read it, of course, because it's still an object store and not a relational database engine that is has its compute ready for you. But that can be served either using serverless SQL. And talking about serverless SQL, Synapse serverless SQL is not a good performance solution right now, but it will hopefully get there. Databricks serverless SQL has just arrived, which is also quite handy. If you're using Snowflake, you can actually read Delta Lake as well if you want. But why would you? You have a relational database engine, you don't want that. But it is, you can always, of course, also use Spark clusters and have them available either given the time to heat them up or you have them ready during business hours or something else. And you can choose which endpoint to use, whether that is SQL or Spark or just Parquet endpoint if you want. Databricks, being the inventors of the data lakehouse, have announced a bunch of features in 2020, 2021, and 2022 to grow from what Databricks used to be, which was a containerized Spark engine provider for big data and data science stuff, to being a data platform to align with their data lakehouse architecture. You have Photon, which is an analytical query engine, which again allows you to do a lot of typical data warehousing kind of queries faster than your vanilla Spark. So Photon is great for analytical queries such as sums, aggregations, group by kind of queries. Serverless SQL came into public preview this summer. Delta Live Tables is Databricks' take on ETL or ELT or whatever you want to call it, but where you have a nice framework to do your transact load or transform loads workloads. It supports things like loading or updating a table using slowly changing dimension version 2, for instance, or 1. So you can just define when you're building your script saying update yellow cab table using slowly or std2, and it will then handle that insert as a typical slowly changing dimension 2 update with all the cutoffs and startups times and so on. They also have Unity Data Catalog, and Unity Data Catalog is a technical catalog that adds, you can search for files as you can in a normal catalog, even though it might not be the best, most user-friendly. But it also allows for stronger security controls in your Databricks workspaces. It allows for great data lineage on your Databricks notebooks, and it also allows for things like audits, allowing you to go in and check, okay, what's happened to this table, or what user queried this sensitive HR data, and what was the exact query that they used, and what data was returned to them. So these kind of things is in Unity Data Catalog, and it's also a very early start of it, but it seems to be a very promising tool. And again, all of these are components into the data lakehouse architecture that allows you to add your ETL jobs, live in Databricks. You have serverless SQL endpoints as well as Photon, which is now called SQL Analytics endpoints, or serverless SQL on the data lake, and allowing your users to use that. Or you can use Databricks streaming to do streaming analytics. And of course, the Unity catalog goes across all to support governance for your data. Synapse has a lot of the same kind of features that you need. Azure Data Factory, which you've already seen examples of. Synapse Pipelines is not feature parity with Data Factory yet, but it's getting there. You have Azure SQL Serverless for your serverless querying. You have SQL Data Warehouse for your more traditional data warehousing, relational database systems kind of workloads, though you can pause the data warehouse. That it's not a fully decoupled compute and storage solution, for the simple reason that when you pause your data warehouse, even though you're not paying for a compute, you can't really get data out of it using another compute engine. And you have Azure Spark, which we've already seen a sample of, and Synapse Studio, where I showed you the demo earlier, which is a unified place to go look for data. Data Explorer is still in preview if it's not just recently been released, which allows you to do time series data analysis. And then because you're marrying that into the Synapse experience, you can do big data transformation using containerized Spark. You can use Data Factory to transform, and then you can use build your IoT data and do querying in Custo in Azure Data Explorer. And my suspicion is that they want to have this single point of contact where you can build notebooks, querying and pulling data from your data warehousing solution, your data lakes, as well as your time series data, and marrying that into one single analytic pane. And of course, you also have stream analytics solutions inside Synapse, which is what's outside called Azure Stream Analytics. You can integrate Synapse with Azure Machine Learning. Right now, it's one way only, in that you can use Spark clusters from Synapse in Azure Machine Learning Studio. But if you build a machine learning model in Azure Machine Learning, you can export that as an Onyx file, import that into your SQL data warehouse, and do data science or execute machine learning models from a T-SQL script. And Synapse Analytics is the second data lakehouse compatible system. If you listen to Databricks, who were the ones who coined the term. I know that Redshift or Amazon Redshift are positioning Redshift to be a data lakehouse compatible system as well, but last time I checked, they weren't fully there yet. But Synapse supports Delta Lake natively in Azure Spark. Synapse Pipelines as well as Data Factory supports Delta Lake source and sink, and serverless SQL pools reads Delta Lake tables and can build views on top of it. And I'll show you how that can be done, but we will not. I pre-ran that query, and you'll understand why. So first of all, to be able to read the Delta Lake, you need to build an open row set query. If you bulk load all the data and files that are inside the yellow chip data folder we looked in, specify that it's a Delta Lake type table, and then you have to define the schema, and then you can query it. And this is what I mean by you can query it as it is, and afterwards you can build a view on top of this. That means that an end user connecting to the serverless SQL or to Synapse using Excel, if you want, or Power BI or something else, will just query a traditional T-SQL query. But for this, to the raw querying format in SQL is using Open Row Set, and I canceled this query after 25 minutes and 50 seconds, and it wasn't done yet. And this was just by grouping on or selecting, filtering on vendor ID. I'm not very impressed at that speed, to be honest, but that's the way it is. So let's see if we can get the same running here. It's the same script, but it's using Spark SQL. While we're waiting for that, I love the nerd. It might be the nerd in me, of course, but I talked about the transaction log allowing you to do time travel. And that time travel, of course, is dependent on how large your transaction log is. You can define either an auto, a job that automatically runs and truncates or deletes old transaction logs from the system at regular intervals, or you can do it manually, or you can run this notebook at scheduled intervals yourself. But the fun thing is that the command to do this is called vacuum. So you vacuum out your transaction log. This was not, see, nothing particular here. I think I'll have that one. Yeah, so this is, I also loaded trip data from Yellow Taxi into the data warehousing solution. And if I run that, and let's that run while I'm checking. Okay, so it takes some time to heat the cluster up. We'll see if I can come back to that. What time is it? While we're waiting for that, I'll just go through some more slides. So again, Synapse, as you can see from the same kind of architecture diagram, supports all the various solutions that you need in your your data lakehouse architecture. You do your ETL jobs using Azure Synapse pipelines or Data Factory. You do your streaming analytics in Synapse. You do your querying on top of the Delta Lake tables, either using Synapse SQL serverless or using Spark. You can also connect directly from Power BI onto the Delta Lake tables. And then you can use Purview as the data catalog that has the governance of all the different solutions here. The only problem with Purview right now is that you don't have data lineage for the notebooks properly yet. It's for now it's can connect to and use lineage for your pipelines, but it can't use it for the notebooks in Spark. But there are solutions that you can work around it. For instance, there are some open source solutions called Spline, so Spark lineage, that you can then convert into Apache Atlas format and insert into Purview. So there are solutions to work around it. And let's go back and see if I have things completed. Traditionally, of course, we know that things take time in demos, and there was no data available. Oh, that was not the one I was looking at. And of course, it's failed. Yes, thank you. And this is still running. Let's just end that and pretend that that never happened. So my name is Johan Ludvig. You see my contact info here if you need to reach out to me for anything. Are there any questions?